It's a pleasure to be here. Just to let you know, I don't know who's been watching the videos of previous talks, but anybody in a sort of line here, your screens will be televised. So if you're on Tinder or something, just be very much aware that that's going to go public. Good. I'm going to talk about climate change and sustainability, and in particular, I'm going to focus on what mistakes economists make when trying to forecast far into the future. Because, and I'm going to be kind of keeping with the tradition of slightly twisting the knife into economists, but hopefully with some constructive suggestions as to how we can use the economics toolkits to do a better job than the one we are doing, which I will argue actually has been quite destructive to the cause of decarbonising the economy. And that's because, as economists, we're often asked, well, what's it going to cost to decarbonise the economy? The wrong answer is to give a figure, which is what most economists do. The right answer is to say it's endogenous. It depends on the actions that we take today. As Mariana told you in an earlier lecture, innovation doesn't just happen in a vacuum, it has to be directed. And I'm going to argue that because of this, economists not only get the future wrong, but they make the future wrong. Because to the extent that they're actually believed, economists change the way the policy environment works in a way that militates against active decarbonisation. And I'm going to return to this theme of expectations throughout the course of this lecture. But it's an after-lunch slot. We've spent 20 minutes fiddling with the IT. People might be losing their attention. I might not know which computer to press. There we go. I'm going to start with a multiple choice question to wake everybody up. Now, we all know that in order to meet our a 2-degree stabilization target, we have to reduce emissions, greenhouse gas emissions from current levels by about 80% by the middle of this century. If we're going to meet the more ambitious 1.5-degree target that politicians talk about, we will have to reduce emissions by, well, close to 100% to get us towards what's called net zero. Just think of that as zero for now. Now, the question I'm going to ask is what if instead we became very cavalier and we said, look, let's stabilize at 5 degrees. Now, 5 degrees is a really horrible place to be. The last time the world was 5 degrees warmer was well before humanity was on the planet, some 30 million years ago during the Eocene, the end of the Eocene period, a period characterized by alligators on the poles. The last time the world was 5 degrees cooler was a mere 10, 20,000 years ago, the end of the last ice age. At that point, there were ice sheets over New York. So this is a very different physical landscape. And we're talking about these kinds of changes happening over a period not of thousands of years, as is conventional, but maybe 100 years because of a couple of hundred years because of human activity. So radical transformation of the physical and human geography of the planet if we were to allow the world to warm by 5 degrees. So the multiple choice question is, given that we're going to have to reduce emissions by 80% to get to 2-degree stabilization by mid-century, we're talking about net zero for 1.5 degrees. What would we have to reduce emissions by relative to current emissions in order to meet this 5-degree stabilization target? And the answers, there are 4, split into 4, as you can see there. 0 to 25%, 25 to 50, 50 to 75, 75 to 100%. So what I want is a show of hands. How many people think that meeting a 5-degree stabilization target requires a 0 to 25% emissions reduction? Okay. What about 25 to 50? Okay. Yeah. 50 to 75. Yeah. And it's a lot bigger, this place, than appears on the TV. That whole kind of left flank. And I should aim my presentation more towards you as well. And the final selection is 75 to 100. Okay, a few hands there. Well, the correct answer is indeed 75 to 100. And the clue is in the title. It's about stabilization. Now, the thing to remember about climate change is it's not the annual emissions of greenhouse gases that cause temperature heating. It's the stock of greenhouse gases that matter. These greenhouse gases, they sit in the atmosphere for tens, in some cases, hundreds of years. So in order to get that stock to stabilize, think of a reservoir or a bathtub or whatever, you have to switch the tap of emissions down to whatever the Earth can actually absorb. Okay? So it doesn't matter whether you're going to stabilize at 1.5 degrees or 2 degrees or 4 degrees or hell in a handbasket flaming toast degrees. We have to get net emissions down to 0 in order to stabilize. Otherwise, the temperature just goes up and up and up and up. So basically, we either do this transition the easy way, by managing our decarbonisation, or we do it the hard way, by creating such a hostile climate that effectively we reduce emissions because nature depopulates us and gets us out of the picture. We want to avoid that, but it's a challenge. And that's what I'm going to talk about today. So bearing in mind what I just said about stocks and flows, you might want to know, well, if we're going to meet a 2-degree target, how much more room is there in that budget, in the bathtub, in the reservoir, for us to emit further emissions? And that's what's this. I hope you can see it. The lights are quite bright. But what this small blue circle shows on this chart, on these charts. The black circle, which is to scale with the small blue circle, and that's the important point here, is how many readily accessible fossil fuels there are in the ground. Known reserves, readily accessible. We're talking coal, oil, and gas. Now, if we're to meet a 2-degree target, we have to stick within that blue circle, which means that the bulk of these fossil fuels will either have to stay in the ground, or if we burn them, we're going to have to capture and sequestrate and store the carbon. Now, that is clearly very ambitious, and of course, it's not surprising that economists like us are asked, what's the cost of making that kind of transformation to an economy which has been driven by fossil fuels since the Industrial Revolution to effectively decarbonize to an extent that we actually leave a lot of the stuff that we know we can access and burn in the ground? Well, here is the answer. What? You can't see it? Well, you're not actually expected to see it. But this is a collection of the wise and the great, some of the best economists on the planet, asked by the Intergovernmental Panel on Climate Change to predict what the cost will be of reducing emissions consistent with a 2-degree pathway. And this is a forecast, wait for it, for 2100. So we're asked, what's it going to cost to meet a 2-degree pathway in 2100? Drum roll, please. There's your answer. 2.9 to 11.4 degrees. Percent. Okay, I can go home now. We know the answer. But hang on a minute, okay? Firstly, the comedy decimal place ought to start ringing alarm bells, right? You know, we're talking about such precision, spurious precision here, over a period of 80 years when economists struggle to predict GDP over 2 years to 1 decimal place. But more importantly than the spurious precision, in my view, is the fact that this just does not pass the sniff test. We will have had 80 years of trillions of dollars worth of investment going into decarbonizing the planet. We'll have had a uniform global carbon tax, because that's the scenario we're looking at. We'll have had our best innovators and entrepreneurs put it to the task of reducing emissions. It will have cost a lot of money in terms of investment, but this is the difference between stocks and flows. When you get to the end of it, what do you have? You have buildings that don't leak. You have energy that's provided from the wind, from the sun, from other sources. You're no longer tying up important factors, digging stuff up from the ground, putting them in ships, in trains and pipelines, transporting them halfway across the world, refining them, burning them, losing huge amounts of that power in the grid or in combustion engines. And we're saying that that world is going to be less efficient, the clean world, than the one where we do all those wasteful, inefficient things. That just doesn't pass the sniff test. It's simply inconceivable to rule out that the world will actually be not just cleaner, quieter, more livable and sustainable in 2100, but actually be more innovative, productive, and prosperous. And yet, that's exactly what these economists do. And let's try and find out what it is that economists systematically get wrong in overestimating some of these costs. And it is systematic. The IEA consistently, this is the International Energy Agency in Paris, the world authority on these things, some of the smartest people you and I will ever meet, they work there. They consistently overestimate the costs in their forecasts of renewable energy. They understand that as you deploy renewable energy, learning by doing means that the costs come down, but what they always get wrong is the doing. They consistently, and that's what this chart shows, underestimate the degree of deployment of renewables. This is renewable capacity excluding hydro, so it's primarily solar and wind. The thick blue line you see to the left is actual outturns, actual capacity that's been invested in generating electricity. The little lines that fan out from this is each year's World Energy Outlook that the IEA puts out. And you see that they get it wrong, but they not only get it wrong, they systematically get it wrong year after year after year in the same direction. They underestimate how much deployment takes place. And it's not an accident. There are reasons why the IEA, and indeed virtually every other economist since I've been around, has underestimated the degree to which renewable energy costs have come down and the degree to which renewable energy has been rolled out. And I want to say a little bit about what it is that causes this misestimation and what we might be able to do with it in terms of applying economic methodologies and toolkits. This is just a silly chart that kind of shows you, I mean, if those of you who fly into London and look at the North Sea and you see some of these wind farms and they look pretty impressive, they're little tiddlers. Okay, they're about the size of St. Paul's. These are the vintage that went up in the kind of early 2000s. The stuff that's going up now, just look at it. It's bigger than the Shard, or the same size as the Shard and the Eiffel Tower and so on. And the energy that these things generate is logarithmic. It's more than proportional to the size, whereas the cost is actually inverse logarithmic, less than proportionate to the size. So their efficiency goes up and up and up. So we look at this challenge that we saw before in terms of decarbonization, and we worry about how we're going to do it. And then you look at the actual numbers, and you begin to see that maybe this isn't as much of a challenge, at least in terms of energy generation, as we thought. Solar PV costs have come down by roughly sixfold since the start of this decade. The costs of wind, a more mature technology, have come down by about 40%. They're both now close to grid parity. That means they're competitive with coal, gas, and in some cases oil, and that's without the presence of a carbon price. Okay, the wind doesn't always blow, the sun doesn't always shine. We need some kinds of storage to counter the intermittency problem of renewables. Well, the good news here is that battery technologies as well have come down by something like fivefold over the start of this decade, maybe a little bit more, such that many of the leading authorities predict that come 2030, not that far away, just over a decade now, wind and solar will be so much more cost effective across the world than coal and gas that not only will no one in their right mind be investing in coal and gas generation, but actually it will make more sense to scrap existing coal power stations, which are perfectly workable, in other words, the kind of power stations we're investing in now, and replace them with renewables and just swallow the sunk cost. That's how much cheaper the operating costs of these renewables will be when combined with appropriate storage technologies. So that tells us something that the economists really did miss. And it explains why, if you look at actual investment in renewable energy the world over, this is global generating capacity in 2016. It's been a similar story throughout this decade. Investment in renewable generation outstrips that of fossil-fueled coal and gas. And that excludes hydro, just the wind, solar, geothermal, that kind of stuff. Okay, the stock of electricity generating capital is still predominantly fossil fuel based, but that is changing because the flows into that stock, the investment is very much renewables based, and as the existing stock reaches the end of its lifetime, we're going to see the stock also become predominantly renewable. This is a revolution, it's a tipping point, it's a transformation. We aren't going back. Coal is finished, okay? And we'll talk a little bit more about that. But it's not just here. We know about electric vehicles. There isn't a serious, find me a serious auto manufacturer now that is committing large parts of its scarce R&D budget into developing the combustion engine. It's all about EVs, it's all about automation, it's all about autonomy. And we're going to see those kinds of revolutions, those kinds of tipping points from one network to another which characterize these cost reductions taking place across the board. It's just that those kinds of tipping points are very difficult, indeed impossible to model by economists because they bring about path dependencies and multiple equilibria, which by definition are difficult to model. And it tells us something about what we should be saying about the future rather than how we might be predicting it. And I'll come back to that at the end. But it also changes the psychology. A lot of what I'm going to talk about is about expectations and psychology. When global leaders met in Copenhagen just over a decade ago, the talk was of burden sharing, right? All of us rolling up our sleeves, getting together, sacrificing ourselves for the greater good, for the good of the planet, for the good of future generations. That has changed. By the time we get to Paris in 2015, the talk was not so much of burden sharing, it was about opportunity, it was about self-interest, it was about, look, can we do something to reduce emissions that we can take back to our electorates and say this doesn't depend on other countries doing stuff because actually we can generate our own co-benefits domestically. And so So it was based on voluntary contributions rather than any sense that there were these kind of legally binding obligations. It turns out that opportunity breeds cooperation in a way that burden sharing and sacrifice does not. Burden sharing sacrifice tends to lead to distrust and ill will and waiting for your competitors to move before you and a race to the bottom. Opportunity changes the equation quite substantially. And I'll skip through some of these charts in the interest of time. If we can get some questions at the end, that will be great. But an obvious free lunch, if you like, in terms of opportunity, if we reduce waste, if we make our buildings, our energy, our vehicles, our transportation more energy efficient, then we save money in delivering the same outcomes. And there's plenty of scope for that. And you can look at the slides in more detail at your leisure later. Another very important co-benefit of decarbonisation is pollution. Now, there are various measures of this. They take different approaches. Some look at quality of value of life. Some look at the value of lost productivity or the cost of additional morbidity. They all come out with eye-wateringly high numbers when assessing the cost of particulate pollution, not greenhouse gases, the stuff that we breathe in urban environments every day. A recent report by The Lancet estimated that about 6% of annual global GDP is lost through pollution. 6%. Nobody's even talking about investing 6% of GDP to decarbonize, and yet we casually accept that as a consequence of local pollution. Just one particulate alone, PM 2.5, is responsible for some 400,000 premature deaths in Europe. That's about 2 to 5% of European GDP equivalent. In China, those numbers go double digit, in India as well. Okay, these are really big numbers, and if we can begin to tap into some of these pollution costs by providing more compact, less sprawling, less car-dependent urban environments with public transport, cycling, and so on, amongst other things, and we start closing down our coal power stations, we will make a very dramatic difference, not just to emissions, but actually the quality of life and the livability of our cities. Congestion, another co-benefit. Time wasted sitting in cars, which could be spent either doing more productive things or enjoying leisure. That costs the EU almost up to 1% of GDP, but when you start going to developing countries, those numbers go close to 5%. And of course, in major urbanizing areas with weak transport systems, anybody who's been to Jakarta or Sao Paulo or Beijing will not be surprised to find that up to 10% or more in China's case of GDP is lost by people idling their time sitting in traffic. Again, that can be reduced at the same time as reducing emissions. You won't be able to see this chart. That doesn't matter. The point here is this is an advert that came out just before the Paris Agreement in 2015, and it talks of 6 million companies around the world seeking an ambitious climate deal at that meeting. And this is important too. It's another aspect of the political economy that economists miss out. And that is, to begin with, you'll get great resistance from incumbents who will try and resist change. Whenever there's a change, the beneficiaries tend to be very diffuse. They're all of us. In the case of climate change, it could be future generations. In terms of companies and innovators, they're often innovations that have yet to fully mature or be deployed, whereas the losers know exactly who they are, they know how much they're going to lose, and they know exactly which politician's ear to bend. And so we tend to get inaction. After a point, you reach a tipping point where enough new producers and business lobbies become established that they begin to start lobbying for accelerated change. And that starts to change the equation. The politics changes. Combine that with the lower cost, so you don't have these kind of scare stories about consumer bills. Combine that with the fact that you can develop new institutions to try and streamline some of those policy deployments and so on. And you start to see that the world changes in a way that's very much outside the scope of a standard economic model. And it's all based on the understanding of these opportunities. The shift from costs and burden sharing to understanding that this is one of the fastest growing markets. World trade in environmental goods and services vastly outstrips world trade in general. Sustainable companies have consistently outperformed their peers over long periods of time, and the share prices of heavily fossil fuel dependent sectors has very much lagged share price indices, aggregates like the S&P 500. And we've seen increasingly companies beginning to go to the wall if they're excessively carbon intensive, and that process will continue. And big investors, for example, Norway's sovereign wealth fund, you may have heard last week, not only intends to divest from coal, but is now looking to divest from small oil and gas companies. This is Norway. You know, this is Europe's biggest oil producer, and they're thinking that this is not their road to sustainable investment in the future, and so they're thinking that they'd rather put Norway's oil wealth in something that is a bit more resilient to the kind of economy that we're going to go and see in 2100. US coal producers are going to the wall. We'll say a little bit more about that in a minute. And a lot of the multilateral banks are also beginning to divest some of the more carbon-intensive sectors. Increasingly, they're looking beyond coal as well. Again, this shift from burden sharing to opportunity, of course, underlies why, and this is often little mentioned, everybody talks about the Paris Agreement, but they forget that a year before the Paris Agreement, there was this landmark agreement between the US and China to both act to reduce emissions. Now, at that point, we had the EU acting very strongly to reduce emissions. We had Obama committed to decarbonization. We had China acting strongly as well. That's about 3/4 of the world acting. It's very hard for you to say, oh, I don't think the politicians are going to do it. It's all a bit of a kind of hoax. It's not going to happen. Let's just kind of, you know, bury our heads in the sand and hope this goes away. When 3/4 of the world, basically the world's biggest markets, are moving in this direction. It makes sense, if you're a business person or anyone else, to think about whether your business or whether your economy is resilient to that kind of world, even as a sort of risk management and hedging strategy. Even if you don't believe it as your central expectations, you ought to sit up and start thinking about what would you do if this does happen. And of course, when you've got 3/4 of the world moving, it's very difficult to stop that kind of momentum. Psychology, expectations really, really matter. What goes on in people's head? I mean, if you're a business person or a mayor or a politician or even just a, you know, average citizen, and you're told that this isn't going to happen, the technology costs are really expensive. If you want to invest in renewable energy or energy efficiency, the financing's niche and expensive. If you want to produce the stuff, there's no markets because no one's really going to do it. Are you going to stand up and be an early mover in investing in this stuff? No. You'll wait for somebody else to move first. But if you're told this is happening, we're going to have to decarbonize one way or the other. The EU, America, China, big players are moving. New markets are being created. The technology costs have collapsed, as we've seen. The financing has gone from niche to mainstream. Actually, will you maybe change your view? Somebody's trying to call in. Maybe we've got a question from Merthyr Tydfil. I'm going to just leave it. Would you act? Actually, yes, you would, because you'd feel that if you didn't act, somebody else, your competitors, would probably steal a march from you by acting themselves. And that's a really important story, which we're going to see played out. Once you change expectations, you change facts on the ground. Anybody who's been to, how many of you have been to Amsterdam? How many have been to Copenhagen? Okay, that's a lot of people, a very cosmopolitan bunch here, and I'm very pleased to see so many Europeans are still here and not being put off by our crazy politics. You go to Amsterdam, you go to Copenhagen, everybody cycles around on bikes. If you ask them why they cycle on bikes, you'll usually get some answer along the lines of, well, we have first-class cycling infrastructure. If you then follow up and ask, why have you got such brilliant cycling infrastructure, you'll often get an answer along the lines of, well, everyone here cycles. Hang on a minute. Well, it doesn't matter which came first, the chicken or the egg. The point is, once you get people expecting to be provided with a certain amount of infrastructure, if you've got cycling infrastructure, you buy a bike. If you buy a bike, you will lobby your politicians for more cycling infrastructure. The physical bricks and mortar investment also changes the outlook, the expectations, and the behaviors. You will hold your politicians accountable for delivering pedestrianization, cycle lanes, public transport, if you live in a dense urban environment. If you're a mayor standing on a platform of congestion charging and pedestrianization in Cincinnati or Minneapolis or Atlanta or any sprawling car-based city, your tenure is probably measurable in minutes. Okay? In Copenhagen, Amsterdam, Tokyo, Helsinki, Paris, these things actually get you votes. So you begin to see physical infrastructure and mindsets start to become very path-dependent, which is why you get some cities that are very dense and urbanization and public transport-based, compact cities, and others which are very much the reverse. Once you've got a car, you want to lobby for roads. When you've got a bike, you want to lobby for bike lanes. Same with electric vehicles. You'll buy an electric vehicle if there's a plug-in point. You will want to invest in plug-in points if lots of people have electric vehicles. For a while, shifting to that network is very difficult, but when it happens, it will gather its own momentum and become irreversible, because you don't want to have two networks at the same time. You can't have two networks at the same time. So we have these big shifts, these changes in expectations, these changes in facts on the ground, these reductions in costs, and of course, it becomes much easier to talk about opportunities. And when you talk about opportunities, you get collaboration, you get voluntary action. Of course, you've got an agreement in Paris that was far more ambitious for all its flaws and limitations. You've got virtually every country in the world coming together and committing to decarbonization at a level which is applicable domestically. That was a landmark, okay? We're not going to, we're still struggling to see it achieved, but the direction of travel is correct. Some of you, of course, might have been thinking when I showed pictures of Barack Obama, oh, come on, the world moves on, try and keep up. Well, actually, I think the story of Donald Trump and his commitment to pull the US out of the Paris Agreement and his graphically displayed commitment to push fossil fuels and coal actually shows us why we have reached this global tipping point. Because 10 years ago, had the Americans said, you know what, we're pulling out of a global climate agreement, we're not going to play our part, India, China, other developing countries would have said, well, you know what, bugger you. If you're the richest country in the world with the largest, responsible for the largest stock of emissions, and you're not willing to play your part, take your share of the burden, then we're not going to pull the ladder from under the feet of our own citizens who are struggling with endemic poverty. You've developed on the back of fossil fuels, and you're telling us that we can't? Forget it, the deal's off. That didn't happen this time. There was a palpable sense by which China and India said, okay. In fact, I think a lot of Chinese and Indians were really quite pleased, because if this is the global market that's growing faster than any other, the first thing you want is your competitor hamstrung. We've seen the Americans do this before, by the way. The car industry lobbied for low gas prices, low petrol prices in the US for decades, and they succeeded. But they lobbied themselves to death because American car producers weren't under constraints to build efficient vehicles. So they built these heavy gas-guzzling SUVs that, when oil prices did eventually rise, the rest of the world didn't want to buy. They wanted to buy the European and the Asian equivalents, which were much, much more efficient, fuel efficient. And as a result, much of the US car industry had to go to the wall or be bailed out by the government. That's what America is now doing to its renewable energy and energy efficiency sector. Thankfully, there are a lot of cities and a lot of states in America which are more enlightened, which understand economic progress, and which are continuing to push for investment in the kinds of areas that actually have a future. I mean, Trump may dig coal, but nobody else is digging coal. It's ironic that the US administration's own body looking at energy forecasts now predicts that coal use in the US will be lower than it was under Obama's Clean Air Act. Irrespective of what Donald Trump has tried to do, the economics of coal make no sense. You have to really try hard to make coal stack up economically. So Trump is kind of powerless on this one. He's going against the grain, and he's frankly being ignored. It's too late. He's behind the curve. But he may be in trouble too, because actually companies and indeed politicians are facing another threat, which is litigation risk. We've seen, you may have read a couple of months ago, New York is suing ExxonMobil. I think it's suing other oil companies as well. These companies have been knowingly investing in producing stuff which is causing everybody damage, and yet they've carried on doing it. So sue them, and indeed they are. And they're not the only ones. There are cities and counties in California, Colorado, Washington, and Maine. They've all filed lawsuits against oil and gas companies. The latest LSE Grantham Research Institute Global Trends in Climate Change legislation identified 25 climate-related lawsuits brought against governments and their representatives, the people that allow these fossil fuel companies to damage their populations. And that number is rising. Let's look at some of the changes that have happened over the last 6 years, which nobody, least of all economists, ever predicted. Renewables, as we've seen already, now dominate energy generation investment. LED lighting, in 6 years, has gone from 5% of global lighting to more than 40% of the world's market. In this country, coal has gone from over 40% of electricity generation to under 5% in 6 years. In Norway, plug-in electric vehicles have gone from 5% of sales to 50% of sales. All of China's car market growth is down to electric vehicles right now. And we've seen a doubling in climate laws across the world as legislation is rolled out to try and bring in emissions under control. And perhaps most importantly of all, a number of institutions are starting to subscribe, in this case to the Task Force for Climate-Related Disclosures recommendations, but basically to a principle of investment that says we don't want to invest in companies with high carbon footprints. Why? Not because we're environmentally conscious, they might be, but because it makes no sense. These companies aren't fit for the future. They're not resilient for the kinds of world we're going to live in. They will be undercut by technology costs, which are competitive, and by a policy environment that is hostile. In fact, they're not only demanding that companies disclose their emissions, they are increasingly demanding, shareholders are demanding that companies actually publish their forward look, their strategy for a world which decarbonizes faster than we expect. The kinds of world we're talking about, where costs come in much faster than we think, where tipping points are reached, where new networks are applied, where the politics and the institutions start to change. They're asking themselves, are these companies going to be in business? Do they have a role to play in that kind of future? If not, I don't want to invest my money in them. Unfortunately for economics, most of the conventional models miss this. They can't cope with the multiple equilibria that this kind of feedback mechanism, these kinds of parts dependencies imply. There is a structural bias. We've seen that already. They systematically overestimate costs. They systematically underestimate benefits. They deal badly with structural change. And there's a joke, I don't know if you know it, which has a physicist, an engineer, and an economist. They're on a desert island and a tin of beans washed up and they're hungry, they want to open it. The physicist starts and she says, okay, I've got a great idea, mix of Charles and Boyle's law, we can put it under the sun, the tin will expand, it'll burst open, we eat the beans. Nice. Turn to the engineer. Engineer says, no, better idea. We stick it under the palm tree, we use a fulcrum and a pivot and that coconut with a lever and we'll just, jam open the beans and we'll eat them. And they turn to the economist. The economist scratches her or his chin and goes, assume we have a tin opener. Well, maybe you have to be an economist to find that funny. But that's exactly what economists do, right? They say, well, we don't know what the future is going to be like, so let's assume we know the technology costs, let's assume we know the institutions, let's assume we know the behaviors, the tastes, and the preferences. Well, now we can tell you that the cost is going to be 2.64% of GDP. Great, but you've assumed everything we want to know. That none of that is in the model, and it can't be in the model because all of that is path dependent, all of that is endogenous. They struggle to deal with these dynamic increasing returns that we've talked about. They struggle to deal with this disruptive technological change. The move from one network to another, the feedbacks from technologies to institutions, to policies, back to technologies. That kind of feedback is not in the model because it yields these multiple equilibria, and a model needs a unique equilibrium on which to converge, otherwise it falls over. So you have to give it the structural qualities that they don't have. Don't take my word for it. Many much more illustrious and prestigious economists have said much the same thing. Professor Robert Pindick, models tell us very little about climate change and how we solve it. Nick Stern, models may be profoundly misleading on an issue of great significance. Ackerman and Stanton, models are not remotely consistent with recent research on climate impacts. Wow. Paul Romer, economic models have become post-real, which is putting it mildly. Simon Wren-Lewis, models maintain internal consistency by sacrificing external consistency. Sacrificing external consistency, i.e. they don't match the real world. Great, fun for economists. There's a great paper actually by Paul Romer talking about the problem with macroeconomics. You should look it up. And he basically says that they're all wanting to publish in important peer-reviewed publications, and they don't care whether their methodologies actually say anything meaningful for the rest of the world. Andy Haldane, the chief economist of the Bank of England, wrote a paper in last year's Oxford Review of Economic Policy, basically slamming economists for not citing or looking at other disciplines. Other disciplines cite other disciplines. Economists are completely kind of introspective. And as a result, they miss out much of what we should care about. Economics is supposed to be about behavior and people. Bill Nordhaus, who, together with Paul Romer, won the Nobel Prize this year, even he's saying that there's no serious attempt to estimate the economics of tipping points. Well, if they characterize the world, then we're in trouble. The OECD actually says that if you did this properly, the OECD, this is the most sober bunch of individuals you'll ever come across. They're saying that if you did this properly, you wouldn't be talking about cost to GDP, you'd be talking about 5% increases in GDP by 2050. Again, no reason, I'm going to repeat this, but there is no reason that economists or others can tell you why a post-carbon society would not be cleaner, quieter, safer, but also more technologically advanced, efficient and prosperous than the kind of world that involves burning lots of fossil fuels. So how do we deal with this? Well, we need to be much more open to other disciplines. We need to learn from history, the history of these technological changes, these structural changes. We need to have the kinds of challenges that you've heard in this lecture room. We need to learn from geographers about urbanization and other land use policies, which are key to using resources more efficiently. We need to understand social psychology. I keep repeating about the impact of expectations. Economists have two forms of expectations for the most part, adaptive and rational. Adaptive means you just look backwards. Rational means you know absolutely everything with perfect foresight. I don't know if any of your friends come up to you and say they either have rational or adaptive expectations. You should probably steer clear of them, because that's not how people work. So we need to look at how people work through agent-based modeling. We need to look at complex systems theory. We need to look at real options theory, which says, look, if we've got these potentially irreversible, non-marginal changes, what might we be prepared to pay to prevent them from happening, from not having that door close irredeemably? You know, fish stocks reach a point where they don't renew themselves. The West Antarctic or Greenland ice sheet starts to melt irreversibly. The Amazon dies back. The tundra releases methane. There are all these tipping points and thresholds that we'd like to avoid, and we should be able to value the cost of not insuring against their happening, and so on. I mean, you know, any number of fields across the world could tell you, could inform your judgment as to how the world actually works in a way that isn't in your standard economic model. We're kind of running out of time, so I'm not going to go through this. You can look it up later. But of course, the optimal policy mix needs to be effective, but it also needs to be credible in changing expectations. That requires carbon pricing, because that's transparent and non-discriminatory. It sends a signal to all producers and consumers without policymakers or regulators picking any particular sector and then opening themselves up to lobbying and so on. But it's not enough. You're going to need standards and regulations. You're going to need support for R&D. You're going to need to help roll out networks which are subject to economies of scale. All these things which are subject to various kinds of market failures that require public intervention. But you're also going to need, and Mariana talked about this, she says it's not a market failure. I would argue it is a market failure, but it's a dynamic market failure to start to steer and design and move the future in the direction you want to go. And only policymakers are able to do that in such a way that you can coordinate expectations in the way that we've seen. And that requires investment in institutions, investment in social capital as well. If you undermine your social capital by not investing in it, well, we're beginning to see across the world what happens if you don't invest in your social capital. And that trend is going to continue. And you won't be able to address these intractable public sector social problems if you neglect your social capital. Great, so we've seen the Sunny Up plans. I'm telling you, everybody, you've heard that the world is in crisis, and I'm telling you that actually we can solve this if only there were the general political and personal will. So I'm an optimist. Well, not so fast. I'm a conditional optimist. We really are in trouble. The world really is in crisis. We have wasted decades not dealing with this. We've locked into infrastructure that's going to be expensive to retrofit or scrap, and we keep pumping. We're still we haven't even begun to reduce emissions, let alone stabilize the stock. The tap into that bathtub is on, and it's on full. So I'm going to end by taking a leaf out of Paul Romer's book. Paul Romer, a man I respect hugely, who won the Nobel Prize last year, and he distinguishes between complacent optimism and conditional optimism. Complacent optimism, he says, is the feeling a child gets when waiting for presents. Conditional optimism is the feeling of a child gets who's thinking about building a treehouse and says, hey, why don't we get some wood and some nails and persuade some other kids around here? Maybe we can come up with something really cool. We don't just sit there and say, let's model the chances of there being a treehouse. Well, assume there's a treehouse. What would it cost? You actually go out and build one. And that's what this theory, and this is where I think economics can help, because there is a theory already out there that really captures much of what I've been talking about. It's just our failure to apply it. And Paul Romer helped develop endogenous growth theory, which basically supports the notion of conditional and not complacent optimism. Endogenous growth theory says that the rate of growth and its complexion and its makeup are a function of the actions we take today. If you invest in computers, people will think of clever things to do with them. If people think of clever things to do with them and invest in software, then the incentive to invest in computers go up, okay, and the power of computers go up. We will not deliver growth, he says, unless we invest in human capital, in physical capital, in natural capital, all the things that generate growth. That's why I, at Cambridge University, am now looking at these things that generate growth and what we call the wealth economy. Before endogenous growth theory, economists basically said you could disappear for 10 years. You go to the beach, sit there for 10 years and come back, and you'll be 10% richer. You won't have had to do anything. Endogenous growth theory said, well, actually, yes, you would have to do something. You can influence both the rate of growth and its nature, whether it's green or brown, whether it's resource efficient or resource extensive. That is down to us. And so he concludes, instead of thinking that we can relax policy choices because policy doesn't matter, endogenous growth theory tells us that, to the contrary, such policy choices are even more important than traditional theory suggests. These feedback mechanisms, these network effects, these tipping points, they need an impulse. They need expectations to become aligned. They need public policy to steer and build that process. So to sum up, we have big challenges. We are in a planetary emergency. There's no way around that. We have to face up to that. There's a lot of change that is afoot beyond just the climate impact, automation, artificial intelligence, big data, and so on. And much of this can be managed, can be steered, and much of it is self-reinforcing and prone to these network and tipping effects that I've spent the last 45 minutes or so talking about. Traditional approaches just miss this. They systematically, therefore, overstate the costs of most kinds of change, okay? They just don't do change very well. Models have their place, but the limitations need to be understood, and they certainly don't capture these non-marginal systemic transitions very well, and therefore are really of limited use in the long run. You can use models for simulations, but you can't use models for forecasting beyond a couple of years ahead, where you can take the structure of the economy as given. A growing number of companies, states, politicians, and so on are managing the risk by taking a strategic forward look and trying to design the kinds of processes and structures that allow them to be resilient in a low-carbon world. And as I've said several times before, this means that, the kinds of effective policy mix that you apply could very well leave the future cleaner, quieter, safer, more technologically advanced, prosperous, and productive than a future which is based on conventional ways of doing things with fossil fuels and so on. But that won't just happen on its own, okay? We need to understand the lessons from other disciplines, and we need to understand that whatever the cost of decarbonization will be, that cost will be a heck of a lot higher if we don't take action to manage that process. We continue to lock into high carbon infrastructure, we continue to lock into high carbon behaviors, and we don't grapple this problem early on. We don't undertake what Paul Romer says and get the tools together to build the treehouse that we want to build. Because if we did, it would be very efficient. And so the punchline for economists is really they should spend a heck of a lot less time trying to predict the future and systematically getting it wrong, and a lot more time trying to help politicians, business people, and civil society build and design that future that we want. Thank you.